All right, we'll start the webinar in just a few moments. We'll just wait for a few people to join. All right, I think we can get started. So hi, everyone. Thanks for taking the time to join us today. We'll be starting the webinar in just a few moments. My name is Tina Fabiano, and I'm on the NDAC Marketing and Engagement team. In a minute, Steve Hanley, our Vice President of Product, will be presenting today's webinar and Q&A session on generating beautiful and interactive plots using Plotly. This is the third webinar in our Python for Mechanical Engineers series. If you missed the first two, we'll send out a link a bit later in the webinar to where the recordings are so you can watch them whenever you'd like. During today's webinar, Steve will show you how to use the Plotly Python graphing library to make beautiful interactive plots that enable you to not only understand your data, but also present it, whether it's embedded on a website or in a technical paper. And he'll demonstrate the simplicity of the syntax needed to create these interactive plots. In addition to Steve, we also have Becker Alcott, David Stokes, Connor Flanagan, and Sam Ragusa with us today as panelists. They're all on the NDAC software team and are incredibly knowledgeable on this subject, so we're excited to have them with us to answer your questions. This is a 45-minute session. As you're watching the webinar, don't hesitate to use the question and answer button labeled as Q&A right at the bottom of the screen. The software team will be able to type some answers to your questions in real time. Then Steve and the team will answer any other questions at the end of the webinar. We'll also have some poll questions for you to answer, and at the very end, we'll launch a post-webinar survey. We'd love to have your feedback so we can make sure we're providing you with relevant resources around this topic, and so we can continue to improve our content. We're really excited to be running this webinar today, answering your questions and helping you start using Plotly to interactively present your data. So with all that, I'm happy to introduce Steve Hanley, who'll be taking it from here.
Thank you, Tina. Thank you, everyone. As Tina mentioned, this is our third webinar in our series of introducing Python to mechanical engineers. So do please check out those other ones that we've done if you haven't already. And actually, I'm going to launch a poll question right now just to kind of see how many of you were at some of the previous ones and what your familiarity with Python is. We've been producing these webinars in large part because we've also released our own library in Python for doing data analysis and visualization. So that'll be the topic of some future webinars. So this is really the groundwork before we can show that off. And this is the last piece of groundwork, is plotting data in Python. Okay, let me launch this poll or show you guys the results. So a lot of you have been at the previous ones, at least one or two of them, which is awesome. A lot of you are new, almost half of you, so that's great. Welcome, and a lot of you guys have a mix with some experience with Python, which is awesome. A little recap, again, for those that don't know, Python's popular for good reason. Many different ways to interact in Python and write your code and see the results. So I'm in Google Colab, so we're going to send out this link. I think Tina will chat it out to you. Once you have this open, you can save a copy in your Google Drive. I encourage you to do that so you can follow along and edit in real time. If you also want to run it locally, you can download an IPython notebook to open in Jupyter, or you can download a .py file to open in any Python editor. So the topic today is plotting in Python and Plotly specifically. But first, why do we plot data at all? We do it for two reasons. One is we, the engineer, the analyst, want to understand the data. We want to make sense of it. We want to draw some conclusions and see some correlations between different data sets. And this is where interactivity is so important. When I have a plot that I can zoom around, pan, and change, kind of probe it, if you will, I can understand it a lot faster than if I had to keep generating that image. So interactivity really matters when we're plotting data. The other reason we plot data is to present it and share with others. And this is where beauty matters. I'm a firm believer that aesthetics really do matter. That's why I'm not shy to say we have the most beautiful data recorder on the market. And you certainly need to have good functionality under the hood. But the look and feel of something also really matters. And that's true with plotting data. So before we get into Plotly specifically, I'm going to highlight some other libraries in Python that are popular for plotting data, and that will kind of lead us into Plotly. Remember, in Python, there's many different libraries to choose from, and that's no different with plotting data. So first, I'm going to import a data set. So I'm importing pandas as PD. If this line of code is unfamiliar to you, I recommend check out our last webinar. And then I've read a data frame in that is acceleration data, and I've structured it in this data frame. So you see here I have a column that's the index of the timestamps, and then I have 3 series for the x-axis acceleration, y-axis, and z-axis. So once I get my data in this form, it's pretty easy to plot, and let's go through it. So the first plotting library that people use is called Matplotlib. It's the most popular. It's been around the longest, and it's pretty easy to use, and it's, again, very, very popular. So to create this plot is pretty straightforward. I give it the data frame. Matplotlib intuitively understands that that index is going to be the x-axis of my plot, and it knows there's 3 columns in the data frame, so it's going to present 3 different colors, 3 different lines. And then it gives me this figure. I also edited a couple elements of it: the title, the y-axis label, the x-axis label. I turn on the grid lines, and now I have my figure. Now the problem is it's an image. It also isn't super beautiful, but there are ways you can certainly add a lot of customization to Matplotlib. Another library that's used is called Seaborn, and Seaborn actually uses Matplotlib under the hood. It just simplifies the interface to it a little bit, so creating this figure is a little bit quicker, and they also have a bunch of different themes to choose from to kind of make it easier to create figures to go into presentations or papers. So Seaborn's really nice and easy to use, but again, what you get at the end is an image. Now, in Matplotlib and Seaborn, there's ways you can create interactive figures, but it's only going to be interactive when you're within Python, and it can be a little convoluted to set it up. Another library I want to introduce before I get to Plotly is called ggplot. It's called Grammar Graphics, and I'm not going to really dive through this syntax here to create the plot because it's a little confusing, but I want to highlight it because Plotly was inspired off of ggplot, and they really like this idea of kind of explicitly mapping the data to the rendered image. So you'll see a little bit of that later on. Then the last library before we get into Plotly is Bokeh. Here I finally have an interactive figure. Creating this figure took a little bit of work, more than the other ones where I had to loop through my data frame to add a line for every column, but I get an interactive figure. So it's pretty cool. I can click in here and move my cursor around. I can zoom, and I have interactivity, which is great, but the interactivity gets a lot easier with Plotly. So here is the Plotly library. I've installed it in Google Colab, or I've upgraded it actually. But to install it, if you don't have it already, is just pip install Plotly. And then I've imported Plotly Express, which I'll explain in a moment, as px. So now I've created a figure, which is as easy as just doing px, Plotly Express.line, and I give it the data frame. Plotly Express knows that the index is going to be my x-axis. It knows there's 3 columns of data, so it's going to present 3 different variables, 3 different lines. And then I did an update layout to change kind of the look a little bit, to add a title, x-axis title, and a y-axis title. Now, the interactivity here is off the charts. When you move your cursor around in the web browser, you get these data points are highlighted. You can click and drag to zoom. You can grab the y-axis or x-axis axes to kind of pan around. Another thing that is really, really cool, and I haven't seen in any other library, is in the legend. I can click a line to turn it on or off, or double click a line to isolate it. So the interactivity is really, really impressive, and it's all done in the web browser. You can even download an image of the plot, and that image will download however the plot looks like at that moment that you click download image. So how is Plotly able to create such an interactive image in our browser? Well, there's 3 main systems we need to understand how they work, and that to understand how Plotly works. One is the Python library that we use to write the code. The second is the figure object, and the third is Plotly's JavaScript library. And to visualize this relationship, I created a tree map, which I probably didn't need to do, but it's cool. So I wanted to do that, and I did it with Plotly. So here are my three systems. There's a figure object, which within that object has the data, which has the numeric values, the labels, things like that are in the data element. And then there's a layout element to that object, which is largely independent of the data. It basically maps data to how it's presented. And then there's frames, which are used when you have animations, which we'll see a little later on. So in Python, there's a library, the Plotly library, called Plotly Graph Objects, was the original way to create these figures. And this is where you're explicitly mapping out what the data object looks like, what the layout looks like. And there was a pretty steep learning curve to using that, at least for a beginner. And only a couple of years ago, Plotly released Plotly Express. That was in May of 2019. And Plotly Express wraps around graph objects. So we'll see graph objects in a moment, or towards the end, where you can use graph objects to further customize a plot, but it's so easy to create the plot initially in Plotly Express. So the last piece of the puzzle, but arguably the most important, is once this figure object is created using Python code, the Plotly JavaScript is what renders it. And so web browsers are loading in HTML and JavaScript and then giving that to you in the browser. And so that Plotly JavaScript library gives us that interactivity. But we don't need to know the library or any code within this library. We have the Python library that creates the figure objects that then the Plotly JavaScript library presents. I'm just linking here to an article when Plotly introduced Plotly Express in May of 2019. I recommend checking that out. And I also, if you're doing some research on your own of different Python libraries out there, pay attention to the published date of the article. Articles published in like 2017, 18 timeframe. They'll say Plotly is pretty cool, but it's a little bit convoluted to use. But articles published in the last 2 years since Plotly Express have come out have largely all come to the same conclusion that Plotly Express is becoming the future of plotting in Python. Okay, before I get into some examples and some cool stuff to look at, I do want to give a shout out to Plotly's documentation that I'm linking to here. They have really, really good documentation. I think that because they have such interactive figures, it makes their documentation actually kind of fun to read through, and you can kind of get inspired off of it. So I do recommend checking it out. I also want to highlight, because their documentation is so expansive, I'm not going to reproduce all that here. I'm going to try to offer something that's complementary to what Plotly has on their website. Plotly also has a community forum, which is really has a lot of good questions and answers out there too. So there's a lot of good content to help you get started in Plotly, and hopefully this webinar can help you as well. So let's dive into it a little bit. I'm going to start by showing you how to stylize figures in Plotly, and then I'll go through a bunch of different examples of different plot types. The reason I'm starting with styling of the figure is because I think I can help show you later on when I'm presenting different plots how easy it is to change the style. I also found that understanding how to style figures was a little bit hard for me initially to understand, and I only really captured it in the last couple weeks as I was preparing for this webinar. So let's get into it. I downloaded our NDAC library just to then calculate a shock response spectrum. For those of you that know what shock response spectrums are, great. For those of you that don't, you don't need to know necessarily, but I kind of did some analysis on the data, and I now have a data frame where the index is the frequency, and then I still have the x-axis, y-axis, z-axis as separate elements to that plot. And now if I create a new line plot off of this other data frame, again, I'm just passing in plotly express.line. I give it the data frame, the title, x-axis title, and now I also said y-axis and x-axis I want to be logarithmic. And now I get this log space plot. But this is the base look and feel. I haven't customized anything yet. Again, good documentation in Plotly, but here's an example where I'm going to get a little crazy. So here I'm going to create the figure like I've done before, but now in the update layout, I'm going to do a bunch of random things. I'm going to set a font family to be used throughout the figure. So the font family type, the font size, the font color. Then for my title, I'm defining a different font family, size, and color. I'm also defining the position of my title in title X. The X-axis title, I'm defining a different font theme and color and all that. I'm also changing my legend location and background color, and I pinned it up to the upper right of the figure, and I changed the width and height. Now, obviously, this isn't the most beautiful plot in the world, but I just wanted to highlight some of the elements we can customize. You may have noticed in this text up here that there's some repetition to it, and you start to get sense of a structure. Plotly uses something called magic underscore notation, which means that these underscores in my update layout are actually defining these nested dictionaries. So writing y-axis underscore title is the equivalent of doing y-axis as a dictionary and then the title as a dictionary within it. And the reason I want to highlight that is this starts to make it much easier to write out and define how elements in your figure look, but it also gives you some of that sense of this. When you see an underscore in that update layout, you know that you're in a hierarchy. Okay, so again, aesthetics matter to me, so I want to make a custom theme. So here I define a variable as template light, and I have it being a dictionary, and I define a bunch of custom elements that I want to use later on in my figures. So I like a particular font family, a particular font size for the title and the x-axis. I like my legend below the plot, which I'm doing here. I don't like a legend title. I think that's silly. Everyone knows it's a legend. I like a background color of the plot to be a certain color. Grid lines, things like that, I'm all defining here. I then made two themes. I made one as a light theme, one as a dark theme. So I took a copy of my light theme and just changed some of the colors to basically make it work as dark. Something else you can do in Plotly, which is nice, is when I create a lot of plots and I'm analyzing data, I typically am presenting a bunch of similar plots. For example, a bunch of power spectral densities or shock response spectrums or just acceleration versus time. And they all will have a common x-axis and y-axis title. And so I can simplify when I create figures later on by creating these little templates to define what these labels are. And so now I can represent that figure with my custom theme. It's just two lines to say, I want to use the light theme with my shock response spectrum template to get my pseudovelocity title and natural frequency in the X. And all I have to really pass in at this stage is the text title of my figure, and then I update it. And now here's changing just template underscore dark. Now I have a dark theme. So obviously you don't have to use my templates, but you get the sense that it's very easy to customize. And once you pick something that you like, it's really easy to use that later on and generating plots with just a few lines of code, really too. Plotly has some built-in themes that you can use. And you notice in my themes that I customize, I started with the base one. So I just wanted to show you these. There's a Plotly dark and light. There's ggplot. Again, they're inspired of Grammar Graphics, Seaborn, and a few of them. So you can use those. There's also colors in Plotly. So here I'm showing the different color scales. So this is the default one, but you can pick any of these you like. You can also, and they're just a list of hex string colors. They also have sequential scales, which, as you see, are just a shortened list, and then they interpolate between them. All right, so now I can start getting into some fun examples here where I'm creating a new figure now. It's a bar chart, but I'm passing in my custom colors. So I just use this parameter called color discrete sequence, and then I pass in this list. And I can do the same here when I now update my shock response spectrum with this custom list. So with that, we can start last thing before I get into examples are saving figures. You're going to be presenting data typically and sharing with others, so you're going to want to save those figures. You can save images of all these figures in Plotly. You'll need to use this other library. You need to make sure that's installed. You can also export an HTML file of a figure. And this is, I think, really powerful and impressive, is that once I export this in HTML, I can share it with somebody who, again, can have that interactivity even without having Python installed. There's two different ways to create these HTML files. One uses the Plotly library, the JavaScript library inside the HTML file. So it could be a little large, but you can also, if you have access to the internet, kind of not include that to make those HTML files pretty small. Okay, now let's get into some fun examples. So I've showed you a couple line plots. Now let's do something a little different. So here's a data frame that's like of tabular data. This is from the NDAC cloud. It's basically a bunch of different files, but you can think of these as different tests if you're not one of our customers, and that's fine. So each test has a name to the test. There's a serial number of the device that generated that file. Then there's some parameters that summarize the test, like the acceleration levels and average velocity and things like that. There's a date the recording was created at. And so here's my data frame of kind of tabular data, not just time series. To create my figure using Plotly Express, I do plotlyexpress.scatter. So it's a scatter plot. I give it my data frame, and then I tell it here in this function call how to map the data frame to the presented figure. So I say the x-axis coordinate is going to be defined by the column recording TS. So you see up here, this is one of the columns in my data frame. So now Plotly knows, okay, all these values I'm going to use for my x-axis coordinate. And then here's my y-axis coordinate, is the column defined by acceleration RMS. I want the size of my bubbles to be defined by the recording length. I want the color of the scatter point to be defined by the serial number ID. And I'll explain a little bit more on that in a second. And I want some hover text being the name of the test, the file name. This is as easy to create the scatter plot, and then you update the layout. I use my theme again, my template dark. I define an x-axis title, a y-axis title, and the title of the plot. And now I have this scatter plot of acceleration versus time of all these different recordings. You see when I hover, I get the file name of those tests. But something that might look a little funny is that I had defined my color based upon the serial number. And Plotly is doing something that's pretty clever if you want this to be done, which is it says, oh, serial number is a number. And so because of that, I'm going to use a sequential color scale, which is going to be really powerful if you want to kind of add a color scale based upon some numeric metric to understand something of meaning. But I was actually trying to get separate colors for every serial number of my device, not some sequential scale. And so in order to do that, I create a new column in my data frame, and I just make it as a string type, not a number. And I create a new figure. I decided to use different x-axis and y-axis coordinates, but here I say the color equals the column defined by device. I also here provide that color sequence because there's a lot of different serial numbers in my figure that I'm going to present. So I want to make sure that I give a sequence of colors that has as many discrete values as the number of series that I want to see presented. And so now I see different colors per serial number, and I can isolate them, just double clicking in here. These are all the files recorded by serial number 9680, and that is the scatter plot. This is a function that one of our engineers, Sam, made, which is pretty cool and shows some of the customization that you can have in Plotly and the interactivity. Where that same data frame we provide to this figure, this function that we'll include in our open source library. And then it gives us drop downs. So we can say, okay, I want to see acceleration peak versus pressure. And there's no correlation there, but it's acceleration peak versus acceleration RMS. There's a bit of a correlation. What about velocity RMS versus acceleration RMS? All right, we're starting to see a better correlation. So you can play around with these drop downs, and this is all done in a Plotly figure, which again can be saved as HTML and shared with others to also be able to explore the data. Okay, now let's make a map. I'm just going to quickly refresh the map. One of the things that I'll highlight in Plotly is the only downside is when you have too much data that you're trying to present. And I'm going to explain what that means in a second. So here's a data frame where I have, this is recorded from one of our devices with GPS. So I have latitude and longitude. I also have ground speed, and I still have time. So now I can make a map passing in that data frame and saying use the latitude equals the column defined by latitude in my data frame, longitude using the column defined by longitude in my data frame, set the color to be used the ground speed. And now in that last example I talked about, when you have a numeric color, you get a color scale here, which is actually really helpful. And you see this color coding where when it's this lighter color, I'm driving faster. Hopefully I wasn't speeding. And here's a map. And this was, you can zoom up. It's a really interactive figure. You can kind of do this weird three-dimensional thing. And this is going from Meday, where NDAC is located, to the airport at Logan. And it's a really easy figure to create. And it's really fun to play with to create maps. One thing I do want to highlight is I need a Mapbox token, which you can create for free, up to 50,000 loads per month. So I can't imagine anyone's going to hit that limit. So it's free. Okay, now let's start getting into some crazy plots to make a 3D line plot. Again, with Plotly Express, it's really easy once I have the data frame structured in this way. So I have frequency versus time versus all these different axes. And now I can create a line 3D plot. Again, I pass it the data frame. I say use the x-axis coordinates defined by the column that equals frequency, that's headed by frequency, the y-axis coordinates by time, the z-axis by the resultant, and use also color by time. So here in my plot, I have discrete lines for every slice of time in my data set. I actually think this is the same drive, the same data set as above when I was driving to the airport and back. But now I get, again, different lines per every minute, every 10 minutes or so, every minute. And if I double click in the legend, I can isolate, oh, here's the power spectral density during this one window of time. Now this is pretty cool, and you can see how you can make a 3D plot, but it's a little bit busy, arguably. So another way to do this is to create an animation, which is really easy to do. Is you pass in that line, basically Plotly Express.line, and now you add another parameter for the animation frame and say use the time as actually a frame in my figure. And here now I can plot and animate how the power spectral density changes over time. You can kind of drag and drop in here to see what it is at very specific times. Now this is pretty cool, but you notice that it can kind of animate out of the frame. So what I've done in the next example is I've used graph objects, which I'm going to get to a little bit more in a few moments, to add to the figure. So I created the figure up here, and then using graph objects, I added a trace. So I said, I want to use the x-axis values of this other data set I'm going to add, which is the max of my power spectral densities, the min of my power spectral densities, and the median. So I get 3 more lines that I've added here. And now when I plot it, you see how that it stays within these bounds. And you get a little example of what graph objects can do to expressly add lines to a figure already created with Plotly Express. Okay. Now let's get into large time series. So this is a data set that's got 400,000 data points. And let's render in Plotly, as you saw a minute ago with the map. If there's too much data, sometimes you have too many things loaded, you can't crash the browser a little bit or it won't render the image. There's a couple ways around that. One is to create an image actually of the figure. Now you lose the interactivity in Plotly, but you still can keep things nice and pretty. So I did figure.show and then I said render equals SVG. And now I have a nice image of my acceleration time series. The problem here is this looks like a shaded mess still. So I don't really like this view as much. You also, the order in which you plot the data when you have a large time series like this matters. Whereas if I plotted the x-axis last, which I do here, now you can't even see what is happening in the y and z axes. So what are some other options to do in Plotly and plotting in general when you have large time series? Well, or large data sets in general. One is to use moving metrics. So here I created this function. I give it the data frame and I say how many data points I want you to plot. And it provides back this figure that is plotting the moving max and min and the RMS of every axis. And this now I much more quickly can understand how things change over time. the plot's not going to die because it's there's not too many data points that I'm plotting. I can zoom and get the interactivity and understand maybe other times I need to probe a little bit more. So that's my preferred approach when I have a large time series. But if you really want a shaded mess, there's another library for that that I'll quickly highlight, which is called Data Shader, which basically, given a height and width, will convert a large data set into an image. So it understands how many data points are being tried to plot per pixel. And so it kind of condenses and say, don't actually expressly load the 1,000 data points that are all going to be rendered in this one pixel, just render one pixel that contains all that information. And so with Data Shader, I can pass it back to Plotly Express in image show, which is one of the libraries or one of the functions in Plotly Express to render this. And now I get a shaded mess, but it's still interactive and I can zoom and understand a little bit better when certain events were happening. So here I'm plotting the x-axis, y-axis, and z-axis. I can also merge them together here. And now when I zoom in, I can see the shading to understand, okay, this lighter color, there's only one of my axes is containing acceleration values in that range. The slightly darker color has 2 of the 3 axes, and then this darker color has all of them in that range. Now that was only 400,000 data points. What happens if we have more? So here's 6 million. Again, I get a nice interactive image that's responsive of my data set. Now let me get a little crazy and load in a 400 megabyte file, which has 64 million data points, or it's actually 64 million times 3, and plot that. And now here that renders in about 30 seconds. And once it's rendered, it's very easy and interactive to zoom around. Okay. What are graph objects? So I showed a little bit of that a moment ago, and the big piece was that I was adding to a figure. So here, I'm going to start again with our shock response spectrum. Really easy to just plotly express.line, you give it the data set. And I'm now also, again, mapping my colors to be this sequence. And here's my figure. And what if I want to add some lines to it, specifically lines of half sine pulses that envelop the raw data? So I'm using a function in our library. So get ready for us to be explaining some of this a little bit more in the coming weeks, to be adding a trace to per column in my data frame of this enveloping pulse. And the reason I wanted to highlight up here where I said I'm going to use this color sequence is now I can use that same color sequence when I'm adding these dashed lines. So here's my line type. The color is this particular color in the loop, and I'm going to use a dash type of dash. And now I have these enveloping half sine pulses that I've added to the original figure using graph objects. Also in graph objects, you can create pretty intense spectrograms. So I think there's probably a way to do this in Plotly Express, but we found the easiest way is with graph objects and the heat map. And so here's acceleration over time on a motorcycle, so the engine's being revved. So you see here the frequency content changing over time. And this is still interactive. You get the nice, beautiful hover. You can understand exactly what point in time these frequency contents are changing. Okay, something else too, if you're into shock response spectrums, is creating these 4 coordinate plots or tripartite plots. I'm not sure exactly how to pronounce that, which I won't fully explain here in this webinar, but you can read the blog to understand what it means. But basically at every frequency and pseudo velocity, there's a corresponding relative displacement. These are the diagonal lines going up to the top right, and a corresponding acceleration level lines going down. Now, this is an image I rendered in MATLAB, and it's nice and it looks beautiful, but I'd have to kind of count with my mouse cursor. Okay, here's 1 inch, and this is now 0.9, 0.8. It's a little bit tedious. Interactivity really helps. So I created a couple functions to add this, and we'll include this in our open library. And now I get this interactive version of the plot. So if I want to say here, I can zoom in, and I get the web browser. It's telling me this is the 10-inch relative displacement line. Here's the 9-inch one, and here's my relative acceleration. You see the 100G, here's 90G. So that interactivity really comes into play here in Plotly and makes this plot a lot easier to understand because you can interact with it. Here's another example of that figure from the El Centro earthquake in 1940. So here's the raw time series data. And now I generate the 4-coordinate plot shock response spectrum. Again, you see the most relative displacement was 10 inches. This is that about 10 inches here. And it never exceeded 1G of acceleration. And you get all that from this one plot, which is cool. This plot was created with Plotly Express and then adding all these lines in graph objects for all these different diagonals. Okay, another thing we want to talk about in Plotly is doing subplots. So here I'm going to load in a data set from one of our devices. Our devices generate a lot of data from a lot of different sensors, and sometimes it can be helpful to get a quick snapshot of all the data in that file. So here's one view is a table of just all the different subchannels and how many samples are in it. But I've merged all the raw data into this one data frame with this structure. So I have timestamp, the value, the name of that particular data set that corresponds to that time and that value, and the units. So now I can make a line plot with this data set and say, okay, I want the x-axis defined by the values in timestamp. I want the y-axis defined by the values in my column called value. And then I want to use facet columns defined by units. So that means every, you'll see a second what that means, and a wrap of 4. So now I have this dashboard where every subplot is represents all the data that is of one particular unit's type. And there's multiple lines for the multiple sensors. There's 2 pressure sensors, a lot of different accelerometers, audio, there's Quaternion, which we'll get to in a second. And all that's in this dashboard that is pretty easy to create once I have the data frame structured in the right way. But if I want to see it more as a stack, I'd call that same thing and say, instead say facet call wrap 1. So now I just have the width of 1 plot per. If I zoom around in this subplot, all the x-axis times are linked. So I can see, I think what I was doing here is I put the device outside, I'm not sure. So those are subplots. The last thing before we get to questions is Quaternions. If you guys know what Quaternions are, you probably don't know what they are because they're hard to wrap your head around. So here I did a test. You can see my screen with one of our devices. I rotated 45 degrees, 45, 90, 90, and then I did pitch 90, 90, yaw 90, 90, and I rolled the device a 720. So if I plot the Quaternion time series data, it's kind of hard to wrap your head around what's going on. You can convert it to Euler angles, and it becomes a little bit easier to understand. So here's when I rolled 45 degrees, 45, when I rolled 90, 90. Something weird happened here, which I'll explain in a second. But even in this time series plot, it's a little bit difficult to understand what happened. So using Plotly, I can create an animation, which I do here. So now I see roll, pitch, and yaw as a function on this polar coordinate. So I see I'm going 45, negative 45. Then I do 90, 90, the roll. And I'll just skip ahead a little bit. And when I do my pitch, the red data point, the pitch, the roll and yaw kind of go crazy, and it's very difficult to understand what's going on. The reason that happens is because of gimbal lock, which is a whole other discussion. But one of our software engineers, Connor Flanagan, wrote this code yesterday at like 4 o'clock before the webinar. Thank you, Connor. This is pretty cool, where he takes the Quaternion data and represents it in this view. So now I get the coordinate system. And now when I animate this, which you can do very easily, you see here when I'm rotating it 45, 45, and then I rotate 90. I'm still on 45, 90. And I do the pitch in a minute. So here's my other 90. Now I do a pitch up 90, down 90. Anyways, you can play that out. Let's open it up to questions. Do we get any, Tina? Oh, before we open it to questions, let me ask one question, which is, as you guys are asking us some questions, I just open another poll. How likely are you to use Plotly now that you've seen it? And also, are there some particular areas that you'd want help with in an open library that we're going to be introducing? So a couple of you are trying to answer that question. These questions was great. I'll give you a minute. Are there any other questions, Tina, that I can answer?
There are a few questions. Do you want to start answering them now?
Sure.
All right, so the first one is there a way to add even more interactivity to Plotly with buttons and sliders that will initiate new processing?
Yes, that's a good question. There's Plotly Dash, which I didn't really talk about at all, and that would be a whole other world. But Plotly has another library called Dash, which lets you create figures. Is there, well, you can check this website out. Maybe we'll send a link in our follow-up, but here you get the interactivity that you get in a typical Plotly plot, but the buttons and other elements can call Python code to do additional processing and spit it back to the browser. So it lets you basically make an application that you can view and manipulate in a browser, but being written all with Python code. It's a good question. Let me just share the results too, while other questions are coming in. So a lot of you are likely to use Plotly, which is great. That's exciting that you all want to start using it next time. And then this is really good results on what you guys want to see in our upcoming library. A lot of help generating vibration and shock plots, which is great. Tools for large data sets. That's a great one. This is good. This is really helpful. Thank you, everyone.
All right, so another question that we got is how do you smoothen or flatten time history plots where the sensor records data with an oscillatory zero error?
Okay, it's a good question. So here was that moving metrics plot I made. So and we talked about this a little bit in the last webinar, but in pandas, there's this, what do you call this? A class or a function that you can make a rolling object. So here I'm plotting the rolling. So I do rolling and the window size of n. Then once I have that rolling window, I calculate the max for that window size. If I don't write this line of code right here, the length of my data frame is going to be the same. So the length hasn't changed. So if you have some DC offset that's moving over time that you want to get rid of, you would basically write out df equals df.rolling, your window size of n dot mean. Here we go. So this removes the rolling mean, or you could do the rolling median, and that would be how you do it.
All right, we also had another question that Sam had already answered in type, but it might be worth revisiting for everybody. What advice do you have for exploring larger data sets in Plotly? So for example, I'm looking at the 25G acceleration from a S3 sensor. The IDE file is about 700 seconds, meaning 3.5 thousand rows to plot, which really bogs down the notebook.
Yeah, so again, I would, in this area, I would first do this rolling maximum, and now you can render it a little bit easier and know maybe the peak that you want to focus on, and then you could use this data shader library also if you are really trying to get into it. Did Sam answer anything else? Provide a little more context?
Yes, he had said that resampling the data before plotting is often a good solution for this, and that SciPy has a resample method that works great as well.
Yeah, that's a good example. And that was actually what I did in the very beginning that I kind of glossed over, which is that data set I used, the shock pulse from the motorcycle crash test was sampled at like 10,000 samples per second. And so I applied a low pass filter of 150 Hertz, and then I resampled, which the resample function SciPy can do too. And we should probably include some easy ways to do that in our new library.
So another question that we got is it possible to save the object as an interactive figure that can then be hosted or pointed to in reports?
Yeah, so when you're saving figures here, it's just, once you have the figure open, it's just write HTML and then the name of the figure that you want. And then that's an HTML file you can reference. You can, again, there's something, Plotly includes a way you can host it online, which is called Chart Studio, which is good and bad. I'd recommend just saving an HTML file and then referencing that. You could then host that HTML file in GitHub or some other online source and then just link to it, which is what I do when I write some of our blogs that reference some of these interactive figures.
And a follow-up to that question is, can you embed the interactive figure in Latex and then play around with it?
I don't think, well, in Latex, you can embed if you can embed a iframe, you could do that. I don't know, I'd have to search that a little bit, but if it's in a web browser, you can just, what I did here is I said full HTML equals false. So now this HTML code is actually a div. So I could create a new HTML file and kind of paste that div in there. I don't know if that helps, but
since the PDFs that the LaTeX would be generating are static, the Plotly figures, you just need to export it as an image and then use that image and in your PDF or LaTeX.
Yep, good call. Yeah, so again, you save those as just write image, and now you have that static image. If you're in Jupyter, you can write all this is markdown text. So, and you can render equations and stuff, and then save this as an HTML file, export as an HTML file. It'll be a report with text and equations, still with the interactivity. That's another option.
So there is a follow-up question to a previous one that was thanking you for suggesting the rolling function. So the follow-up is, wouldn't the rolling function then be equivalent to recording data from a lower sampling rate sensor?
Well, it depends on what you did here. So when I did rolling, I'm doing the rolling max and min. So I'm still looking at all of the data. And I'm doing the rolling standard deviation. So this is still, it's just plotting, a step of all these, but it's still analyzing all of them. So it's enveloping the raw data. If you just do rolling and do mean, so if you do rolling.mean, then yeah, that's kind of the equivalent of sampling at a slower rate, but I wouldn't recommend doing that. I would, again, use what Sam suggested and resample. So you actually expressly apply a low pass filter as another option. But when you do rolling.max and rolling.min, that's getting the envelope of all the raw data. It's not missing anything.
So we do have one last question. I'm not exactly sure how to phrase this, but it's asking for a review on Apache superset versus Plotly Dash.
That's above my pay grade, so to speak. I don't know. I haven't dove much into Apache. I've only looked at a little bit in Dash. That is something we want to play with, but we don't have any real experience there yet.
Right, well, that concludes the questions that we've gotten for today.
Great. Well, thank you, everyone. Again, as I mentioned, I'll give it back to Tina in a second, but as I said in the beginning, this is the third part of our series. The next one is going to be us showing our library off, but that library is never going to be done. We're always going to be adding new functions and capabilities to it. So be on the lookout for that. Please tell us things you want to see. Seems like a lot of people are looking at ways to help with large data sets and other help you want. So again, be looking for that open library and get ready to use it to your advantage to help analyzing and visualizing data. Thanks, everyone.
All right, great. Thank you so much, Steve. And thank you everybody for attending today and for all of your great questions. We hope you found this webinar helpful and informative and that you're ready to use Plotly to visualize your data. If you have any other questions or think of something later, don't hesitate to contact us. We'll send out an email in the next few days with a recording of this webinar and links to some helpful resources. Once we close the webinar, a feedback survey will launch. Like I said earlier, we'd love to have your feedback on this webinar so we can improve our content and ensure that we're providing relevant resources that can help you with your analysis. And just a reminder that this webinar is part of our Python for Mechanical Engineers series. Our next webinar on our NDAC open source library will be around the beginning of November. So don't forget to sign up for our webinar notifications and you'll get an email with a link to register for the next one. I've included it in the chat box if you'd like to take a look. Again, from all of us at NDAC, thanks so much for joining us today. We really appreciate your time. Take care. Bye.